built to withstand the light touch of a seasoned safecracker, as well as the punishing 1700-degree temperatures of a raging home fire. We'll show you the massive tools and special techniques required to create something as indestructible as a home safe. Safe manufacturers. They've been called cavemen by other designers in industry. Why? Because their technology is old technology. The safe you buy today is pretty much the safe you would have bought 100 years ago. And why is that? Because it works. And safe men believe if it ain't broke, don't fix it. To see how these strong boxes are fashioned, we decided to meet the cavemen in their cave. We stopped by American Security Products, located in, what else, a very secure-looking building out in Fontana, California.
Well, we make a wide variety of safes, ranging from a UL-listed TL30 safe down to a floor safe with what we call B rating. That's Underwriters Laboratory tested, and what they're doing with high-security safes in that case would be testing it for 30 minutes against certain tools, as disc cutters, drills, that type of thing, giving the consumer assurance that they can feel comfortable about putting valuables inside the safe and knowing that it's guarded by a high-security safe.
Bob Salee has many stories to back up the reliability of the industry's century-old safe technology. These FBI photos show the aftermath of a failed attack on a Chicago jeweler's 4,000-pound composite safe.
Dynamite was put in there and tried to explode the safe. Well, there was diamonds and jewelry and dollars, and this thing was packed full of money and valuables from this jeweler, and they tried to blow the door open and worked all night to get the water in there, seal the door with a sealant, the whole bit, threw the explosives in there, and the safe didn't open.
You may be surprised to see what a safe is made of. It's not solid steel, as many people assume. On this American security safe rated for burglary and fire, there's an outer skin that's 1/8 of an inch thick steel and an inner skin that's also 1/8 of an inch thick. What goes in between? A heaping layer of fire clay. In a moment, we'll show you how this cement-like substance keeps your important documents from roasting like a Sunday duck when a house fire turns your safe into an oven. But first, we should see how raw steel is cut and fashioned into a basic safe shape. For steel up to 1/4 inch thick, powerful shears can cut the lengths and widths that will eventually be bent and welded into a safe. To cut heavier steel, safe men rely upon this ominous-looking device. It literally vaporizes anything in its path.
This is a plasma machine. It's an underwater torch system. It cuts variations of sizes of metal. It goes up to around 1.5 inches to 3/16 of an inch thick.
Director of Engineering Tony Maniaci explains the benefits of cutting steel underwater.
Two things happen. One is that there's an incredible amount of dust and gas that's created by the cutting process. That dust and gas is captured by doing it submerged. The other thing is the noise. With this thing exposed, the plasma arc, it is a deafening sound. It would literally deafen you in a matter of hours if you were to stand next to it unprotected without this water muffler or shield of water that comes out of the nozzle and the plate being submerged. The plasma actually is an arc welding process in reverse. It's done with either oxygen or nitrogen. There is a very special nozzle with which the arc is presented to the steel. And in the process of this pure inert environment and this arc and a particular swirl pattern that's created like a tornado, it literally vaporizes the metal.
Using a machine that can apply as much as 100 tons of force, Oscar Fajardo is able to fold steel almost as quickly as you or I would fold a paper airplane. Oscar explains in his native Spanish just how it's done.
Simply put, we make designs. By changing the block at the base of the machine and adjusting the pressure of the machine, we can create 45-degree or 90-degree angle bends.
Now we are ready to weld the inner skin to the outer and apply the fire clay. This mixture contains cement along with two oddball-sounding ingredients. They are diatomaceous earth and a gardening product called vermiculite. They actually hold water to be chemically released when exposed to the heat of a house fire. The resulting steam released controls the temperature of the inner safe and prevents important documents from going up in smoke.
Steam cannot rise above theoretical 212 degrees unless it's put under pressure. And any breaches in the seals, either through the door gaps or in the body construction, the steam has a pressure associated to it, and it's going to vent out. So if there are any breaches in the seal of the door, then that steam is released and therefore precluding the heat from coming in.
The fire clay in the safe has been oven dried overnight. We now have a very strong, very heavy box that a 4-year-old could reach into and burglarize. It's still missing what many would consider to be the most important part, the door and the lock. Break's over. Time to restart the line. Today we're at American Security Products in Fontana, California, making safes. We've seen how sheet steel is cut, folded, and welded, and then a cement mixture called fire clay is poured between the inner and outer safe skins. This is the material that protects valuable documents from the searing heat of a house fire. Now, let's seal up that gaping security breach in the front of our far from safe safe. Doors are roughed out in the welding area from thick plate steel. The basic door shape is attached to the safe with welds, and the unit is sent down the line to be prepped for paint. Meanwhile, at handle assembly, metal workers are using high-powered drills and presses to create super strong, super tough shafts, knurls, and levers that will join the safe at final assembly. Our roughed-out safes have been shipped down the line to be prepped for paint.
Material cleanliness is obviously the most important part of a good paint job. And with steel, the way we see steel when it comes in the yard, it's terrible. It's filthy, it's nasty, it's oily, it's gone through a lot of very crude processes in manufacturing, which put a lot of imperfections and contaminants in the material itself.
After safes are cleaned and sanded smooth, paint is applied. Here, the painter utilizes a negatively charged water-based paint gun and a positive charge applied to the safe. What we're watching here is actually atomic science on a molecular level.
They're electrostatically sprayed so that the materials are actually magnetically or electrically fused to the container or drawn to the container, so we get good adhesion.
The safe's final factory stop is at the finishing department. Here, decals are applied and the safe receives its final inspection. And this is where the bolt work and locks are installed.
When I get the safe, it's just the door and the body. All this bolt work stuff here there's nothing on it. Once you get these two pieces together, you gotta rivet these together, and then grind up all the burrs and stuff. Then here's the driver where the handle is. So when you turn it turns like that.
On a large safe, the driver may extend as many as 20 large steel bolts into the frame of the safe in several directions.
Well, this would be the locking bolts. When they're extended behind the jambs, that's what secures the door shut. The lock itself only blocks this mechanism, which really is the business end of the safe.
Mechanical combination locks haven't changed much since the mid-1800s. 3 metal wheels are turned by the tumbler until they line up and allow the handle to be turned. It's still a hard thing to crack, no matter what you've seen on TV.
You see a lot of James Bond kind of things where the guy comes up and he files his fingernails and he goes up there and he puts this listening device on there and he starts doing this click, 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 click. And combination locks don't click like that, first of all. Secondly, the techniques that are used in opening a safe like that are very complex, and it takes years of training and practice to be proficient at it.
I'm gonna install this electronic lock.
Now here's a bit of 21st century technology. These new electronic combination locks are forcing even the most seasoned safe crackers back to the drawing board. Here, there is nothing for the burglar to see, hear, or feel that would give away the safe's combination.
The idea with the electronic is it's a one-for-one replacement to the mechanical combination lock. Yet it offers the consumer the convenience of a touchpad. So you can have a combination, in this case, 1, 2, 3, 4, 5, 6, and the lock will cycle open. Now you can see that it only took me a second or two to open that lock. In a mechanical combination lock, even if you really have the numbers down and your dialing technique is good, it still takes you 15 or 20 seconds to do that.
Now that you know what goes into a good safe, don't be fooled by safe-ish looking, not so secure safes featuring bargain basement prices.
A consumer can go into a mass merchant and find safes that retail for $99 and believe it's a safe. And there's a big difference between a security safe that we manufacture here versus a low mass market type product that's made for strictly documents. When a customer goes in there, he sees a handle, a lock, a dial, and a safe and thinks it's burglary protection. And we've known of people putting $15,000, $20,000 in a fire safe, and it's no protection whatsoever.
When it's all sealed up and on the showroom floor, you'd never know it contained vermiculite, and diatomaceous earth, and cement. Better yet, a thief may try to drill on one of these, beat on one with a sledgehammer, or even try to blow one up with dynamite. But now you know his work will most likely be to no avail, because now you know how it's made.